Hello, we're here with Daniel Povey, and today we're going to be asking him some speech to text questions. Okay, question one. How should TensorBoard login look like in a good training and why? Here are some
Oh,
examples from a trained model that Xiaomi released.
okay. Let's zoom in on this. Uh, so I mean, the basic thing people are normally looking for here is that the losses are going down and that they're going down to a small value that's not like. So for the current loss, if it gets stuck above 0.6, then it hasn't converged at all, and you should kill the run. But this one, you see it goes down to 0.15. I think that's normal. The the pruned loss here goes down to 0.03 or something. That's normal. Uh, all of these other values are kind of normal. The grad scale, that's hovering up to around 32. Uh, if the grad scale goes down to zero or it gets very small, it usually indicates some kind of instability. It's causing large gradients that it's to do with the half precision training. Then you get infinities. Anyway, so this grad scale is normal. Learning rate is normal. That should never change. Yeah. Anyway, okay, that's all I've got to say about that.
Okay, and what does
Oh,
it mean? Go up again.
hmm Oh, and this is the bad data set. So I mentioned before about the loss being above about 0.6. Oh, look, the current pruned loss here is above 0.7. Like this is what it looks like when the system just does not discover the correct alignment. And when you see that, it's never going to converge. You should kill the run as soon as you notice that because it should be, look, so in a normal loss, the current pruned loss by like a few thousand batches, it's less than 0.1, right? So it should never be as large as one, except for the first few batches of training, like 200 batches or something. Yeah. Okay, let's see.
Can you go back to
Example
the
10.
first picture?
Okay, 1 second. Uh-huh.
Okay, does
What,
like
what?
the thickness of these lines mean anything? If it's super thin,
Uh,
super thick?
I mean, not a great deal. They're just jumping around a lot because they're not smooth. Their TensorBoard has like a slider that you can slide to control the smoothing. For some reason, it's not visible in this screenshot. Uh, yeah, if they're wiggling around too much, you can adjust the slider in TensorBoard to smooth them. But there is something else that we should look into. So the second example, the second bad example here. Uh, so there's a different kind of wiggling. So in this tot CTC loss on the bottom, you see it's kind of has a square wave. So this is because this is a libre speech training, and libre speech has different subsets. It has easier and harder subsets. And basically it's going through them sequentially. It goes through the easy like 460 hours and then the hard 500 hours. And that's why it changes each time. We actually recently this was an issue in the training script. It was our fault. It wasn't your fault when training that. But we fixed it and it didn't make any difference to the results. It just made this curve smoother. So this doesn't actually really matter that much.
Okay.
Okay.
Okay, I'm not a researcher and my knowledge isn't that deep, but typically problem cases and how to find and fix them would be interesting to see. I see only the loss function. Is it possible to see how the model is improved in TensorBoard or possible to see something like WER during the process?
Well, if you want to see the word error rate, we don't really have a way to plot it, but you can decode it at different epochs using the decode.py script, and that's something we commonly do. Uh, if the model is not converging, something that we sometimes do to debug it. Uh, the train.py script has various options for debugging. One is the print diagnostics option. You do print diagnostics equals true and use FP16 equals false because it's not compatible with half precision. And then you also have the mini batch size because the use FP16 option, setting that to false will increase memory usage. So print diagnostics equals true, have the max duration, and use FP16 equals false. And then you just put that in a file. And then there's various ways that you can kind of analyze that file. We have a repository in our K2fsa organization on GitHub called Analyze Diagnostics that has a few scripts. They're not very well documented, unfortunately, but there's various things we can see from those. And if you suspect that a particular module is not working right, you can look at those diagnostics. Sometimes you'll see something.
Okay.
Okay.
Question 3. How do you train multi-language models? Just mixing dev, test, and train, or only mixing train? What's better?
Well, I mean, typically the reason people don't include dev and test data in their language model training is because it kind of it'll give you unrealistically good results on your test set. If your test set is included in language model training data, it's not really going to reflect how like really new data or unseen data would behave. So that's why people don't do that. Ideally, you get a lot of language modeling data that's related somehow to your task or to what you want to recognize, and then you train on that. Look, it's a whole procedure. We have at various places in the IceFall scripts. I think we have examples of training back-off language models like Kneser and also of neural language models. Somewhere we have like a transformer language model training script. And we have an option somewhere in the decode.py, I think, that you can rescore. Basically, you can decode with that language model. There's different algorithms for that. Like I think shallow fusion is one of them where you kind of interpolate the scores between the acoustic model and the language model. It gives some improvement. Yeah, that's all I got to say.
Okay. Question 4.
Oh, wait, and before we go into that, I want to mention we have a method called LODR, low order density ratio. Basically, it means that we divide by, I think, a bigram or trigram language model estimated on the token level. I mean, the BPE token level. That's a way to kind of compensate for the fact that our end-to-end models, whatever they are RNNT or CTC, they already kind of have a language model in them. So you have to subtract some kind of basic language model before you interpolate with the real language model. So that's what LODR is about. That's generally how we do language model interpolation using LODR.
Question 4. How do you tune parameters? For example, I increased prune range from 5 to 12 in my dataset and got a better WER, but I don't really understand what I'm doing. And also, which parameters should I be touching?
Okay, so about the prune range, I think this is something to do with pruned RNNT, which it relates to the RNNT loss. I'm a little bit surprised if prune range, if increasing it from 5 would make a big difference. It could be your data was somehow hard to align or something, but that seems odd to me. It could just be noise. Maybe your test set was too small. the normal thing that we would tune first is we try to mess with the model size a bit. The number of layers, the width of the embedding dimensions, things like that. So the model configuration, and also sometimes we change the learning rate slightly, not too much, but a little bit.
Question 5. I watched your video how to train a language model. It was interesting, but when I trained only 250 megabytes, it took so much time on 4090 that I think that there must be something wrong. Is it possible to say how long one epoch will take, or are there cases that will run endless? I'll retry that during the next week.
Okay, well, how long an epoch would take would very much depend how on how big your data was. So we can't really say that. Language model training can be on the slow side, and I think normally we don't train for that many epochs. Also, sometimes we train with multiple GPUs. I noticed there's 2 GPUs on this machine, so it might have been better to set like world size equals 2 to use 2 GPUs. Assuming the language model training script supports that. I notice it's also getting 44% GPU, so it's not very full GPU usage. That may be normal for that script. We'd normally hope for that to be like 80 or 100%. Sometimes it can indicate that something else is a bottleneck, like maybe loading data from disk or something. But for a language model, that should be very fast. So I doubt that that's really the issue. It's hard to say much more about that. Yeah.
Oh, would
So
it
maybe that's it.
allude to some issue in the data set?
Well, I don't think there's really anything about language modeling data that would make it slower to train than normal. You could maybe monitor the logs and see if the perplexity seems to be improving. I'm sure it is.
So what would you do to shoot that first?
Troubleshoot that. Well, I mean, to troubleshoot the speed issue, the first thing I would look at is the GPU usage consistently that low as 44%? Because that is a bit low and that's a bit strange to me. Like it could possibly be bottlenecked on disk access. Maybe that's a really slow disk and something about the data loader is a bit slow. But so if you can get, I think there's a program called PySpy that you can get a traceback of a Python program. So you can sometimes get a stack trace from that, and it might help you figure out like where the code is waiting, like what's holding back the code. Is it the data loader or is it something else? Yeah.
Okay, thank you. That was Daniel Povey.
Cool. Bye.
Bye.